So in problem number 42, we're asked which value of n, or what order of the Taylor polynomial we're going to need in order to get an error range of less than 0.01. And obviously, if we can use a smaller number of terms, that would be good. Now, here's something that's not talked about. This is going to be sort of a guess and check. All right. So what I'm going to sort of propose is that we're going to start with 4, and we're going to see, does that indeed give us the error that we need? And if it's not, then we're going to go to 6, and then we're going to, okay? So I'm going to switch over to the calculator. I'm going to switch over to the calculator. Where's the calculator? There's the calculator. So let me switch over to the calculator. And let's start trying different values. Now we're looking for an error, which is going to be summarized by this absolute value, right? We think that the error is going to be biggest at the extreme ends of our interval because we're centered at 0, that negative pi and pi are extreme ends of the interval, right? We already know what cosine of pi is, don't we? Cosine of pi is -1. Okay, so really what I'm going to be doing is I'm going to be saying, okay, let me get an absolute value. Let me put -1, and let me subtract from it the polynomial, which is the 4th order polynomial. Okay? And that 4th order polynomial is 1 minus x squared divided by 2. Oops, screwed that up. X squared divided by 2. Did it again. Try it one more time. Get down there. Okay, divided by 2 plus x to the 4th divided by 4 factorial is 24. Okay, now there's one thing I forgot to do before I typed all that in. I forgot to say, let's put pi and store it into x. So whenever I do this expression, it's using pi for x. Right? Now, when I put in pi for x, and I ask what this error is, I get 1.12. Is that number less than 0.01? Nope. So 4, not big enough. So let me do it again. But this time, I'm going to add on to it the next term, which is what? Second insert minus, and that's going to be x to the 6th divided by 6 factorial, which I do not know off the top of my... No, I do know. It's like 720. But it's getting to the point where I'm going to want to have the factorial just done for me.
You're right.
What's that? It's 720, but, you know, I'm not going to show off. Okay, so now we go to the 6th order, and we're looking at that error. Again, that expression that I'm evaluating is the absolute value of -1, the real value of cosine at pi, minus the polynomial that's going to estimate it. Still not small enough. So, second, enter. Let's add on the next term, which is what? Second insert plus x to the 8th divided by, and I'm going to put 8 math PRB 4 factorial. Okay? That number, that error, is still not smaller than 0.01. So, let's do it again. And this time it's going to be a second insert minus x to the 10th down divided by 10 math PRB 4. And so there's our, now we have a 10th order polynomial to estimate it. And hurrah, we are finally less than our suggested error. And so 10th order is the smallest value of n that does the trick, and therefore the answer is B. It's a very grungy problem. 1 second, please.